Okay, so picking up right where we left off, multiplying rational expressions. So if you haven't seen the simplifying rational expressions video yet, please go and watch that because you're going to be really lost otherwise, unless you're just really good at factoring, in which case you're in the right place. But I did factor those, and I did walk you through those pretty well. But if you can do what we did in the last one, which is the simplifying rational expressions video, you're going to be just fine in this one. So here are the steps. We're going to factor all the numerators and denominators completely. We're going to divide out the common factors. Same thing we did when we simplified. We're going to multiply them together and then cancel anything else out if there's anything to cancel out. But anyway, let's try it out. So here's what I would do for D. Breaking the rules a little bit here. When I have something like this, where it's just basically a jumbled mess, there's not really, well, there is polynomials, but there's not like a binomial or trinomial like we have in that problem. It's just a hot mess of a bunch of crazy numbers and variables. So here's what I would do to make things simple in this problem is remember that when you multiply fractions, let me give you an example, 2/3 times 4/5. When you multiply fractions, all you do is multiply across. So 2 times 4 is 8, and 3 times 5 is 15. So 2/3 times 4/5 is 8/15. Simple as that. Okay. Basically, we're going to do that here. We're going to multiply the numerators across. So let's multiply, 2 times 15 makes 30. As far as x to the 4th times x to the 2nd goes, that's going to be 4x's and 2x's makes x to the 6th. And of course, there's a y to the 5th hanging out up there as well. In the denominator, I've got 3 times 8, which makes 24. I've got x squared, x to the 3rd, which makes an x to the 5th. And then I've got that y to the 2nd hanging out down there as well. So let me see if I can't get that a little more out of the way. All right, there you go. So that's multiplied across. The only thing now is simplifying it. So let's look at the numbers, 30/24. Let's start with that. 30/24, both of these are divisible by 6. So when you divide them by 6, you're reducing this fraction, you would get, what would that be, 5/4? So that'll be 5/4. So that part of the fraction reduces to 5/4. Let's look at the x's. You've got 6 x's on top, 5 on the bottom. So the 5 on the bottom are going to cancel with 5 from the top, meaning that you'll have just one leftover x at the top. So again, a visual representation of that. Imagine you've got 6 x's in your numerator. And you've got 5 x's in your denominator. Well, that's going to cancel, 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 leaving you with a single x up there in the numerator. And the same thing works for the y's. You've got 5 y's on top, 2 on bottom. So the 2 on the bottom are going to cancel with 2 on top, leaving you with 3 extra on top. So y to the 3rd. So that would be the simplified version. And that's by far the best way to go about that problem. However, sometimes it's better to factor first and then simplify, but not so much the case in D. I think it's a lot easier to multiply, then factor, versus what we'll do in the next problem, which the next problem we will factor and then multiply. So let's erase what we have up here. Let's do the next one. So here's what we want to do. We are going to leave everything in its factored form. We are not going to FOIL anything. We're not going to do anything crazy. We're going to leave everything in its factored form. We want to make sure everything is factored entirely first. So x plus 2, that group's already factored as much as it can be. The 3x plus 12, though, 3x plus 12, that can be factored. That has a GCF in it. Both terms are divisible by 3. So you can factor the 3 out and get x plus 3 out on the outside and x plus 4 there. So I'm going to simplify. We have x plus 2 on top, and the denominator turns into 3 and x plus 4. I'm going to put the parentheses on this as well, just so to remind me that x plus 2 is grouped together. So the other fraction, the numerator here, x plus 4, well, I can't factor that x plus 4 anymore, so it's going to stay the same. The denominator, though, x squared minus 4, I can factor that because that is a difference of squares, x squared minus 4. So this is an x times an x. This is a 2 times a negative 2. So its factored form would be x plus 2 and x minus 2. So that's what I'm going to put in the denominator here for that x squared minus 4 is x plus 2, x minus 2. So at this point, what I encourage to make things easier is start canceling things out. Now, because it's multiplying, I can cancel out across fractions. So obviously, if you just look at this fraction, x plus 4 can't cancel out with anything. Neither can those in the denominator. And of course, there's nothing here that cancels out. However, this x plus 4 in the numerator here can cancel with this x plus 4 in the denominator on that side. And this x plus 2 on the bottom there can cancel out with the x plus 2 on the top. So leaving you with nothing on the top other than 1. And on the bottom, it leaves you with a 3 and the x minus 2. So our answer is 1 over 3 times x minus 2. Now the reason, let me backtrack a second because people are wondering, why can you cross cancel like that? So let me kind of explain why that's possible. Remember, when you multiply, you just multiply across, right? So let's pretend I multiplied together first before actually canceling anything out. Well, if I multiply the top together, it would just be x plus 2 times x plus 4, right? I'm not actually going to FOIL them. I want to leave them in their factored forms, but there they are being multiplied together. And on the bottom, I have 3x plus 1 being multiplied with x plus 2 and x minus 2. So basically, multiplying this together just makes one big jumbled fraction. That's really no different than what it was up here. Now that's one fraction, it's, you can click. Oh, that's a plus 4. Something happened when I erased there. Obviously, you can still see that it's one piece, one big fraction. The x plus 4 on top, x plus 4 on the bottom, x plus 2 on the top, x plus 2 on the bottom. Still the same old thing. So cross canceling is just probably more efficient just to get it out of the way, so you don't have to write it all out like this. Either way, this numerator is going to be your numerator, and this denominator is going to be your denominator, so might as well just go ahead and cancel while you can. So cross cancel works for multiplying. It does not work for adding and subtracting, which we do in a future video, but for multiplying purposes, you can do it. Look at another example, one that's kind of similar to the first one we did. So on top, again, I'm not going to try factoring anything yet. There is no factoring, or canceling things out. I could cancel out, but I'm not going to do it just yet because for these problems, it's just easier to simplify the numerator first, denominator second, and then just cancel out at the end. So on top, I have 20, because 20 doesn't multiply with anything in terms of other numbers. And then x and x to the 7th multiply together and make x to the 8th. On the bottom, 15 times 2 makes 30. And I've got x and x to the 4th, which makes x to the 5th. So 20 over 30 reduces to 2 over 3, because you can divide both of these by 10. And then if you have 8 x's on top and 5 x's on bottom, then these 5 x's are going to cancel with 5 on top, leaving you 3 extras on top. So 2x to the 3rd over 3 would be your answer. Let's look at one we have to factor more, though. So this one, again, let's factor first. Let's see if anything cancels, and then we'll write our answer. So let's factor. This numerator here, 10x minus 40, that's factorable, 10x minus 40, because both terms are divisible by 10, so I can factor out 10. So 10 will come out, leave me with an x minus 4. So there's your numerator, 10x minus 4. All right, let's look at something else. Let's look at the denominator for that. The denominator for that is definitely factorable. It's a polynomial, so x squared minus 6x plus 8. When it comes to trinomials like this, you want to factor using product and sum. So I'm looking for two numbers that multiply to 8 and add to negative 6. In that case, it would be negative 4 and negative 2. And again, since my a value, because it's 1x squared, since my a value is 1, these are my factors. So that means I have x minus 4 and x minus 2 as factors. So there's your denominator, x minus 4 and x minus 2. Let's worry about the other fraction now. On top, x plus 3, I can't factor that, so I'll just keep it the same. It's still x plus 3. The denominator, little simple polynomial there, but we can factor that. It's pretty easy. It's 5x plus 15. Now both of these are divisible by 5, so we can factor the 5 out, leaving me with an x plus 3. So 5x plus 3. So there's some canceling out that we can do. We can cancel this x plus 3 with that x plus 3. And we can cancel this x minus 4 with that x minus 4. So that leaves me with a 10 over x minus 2 times 1 over 5. So again, if something entirely cancels out, it doesn't leave you with 0. It leaves you with 1. All right, so if something disappears entirely, make sure you fill that gap with a 1. So if you multiply these together, we have, or actually, there's something else we can simplify if you didn't notice, the 10 and the 5. 10 and 5 can be reduced. Both of them are divisible by 5, so that can turn into 2, and that can turn into 1. So let's fix that. That can turn into 2, that can turn into 1. Right? Because remember, 10 over 5, you can reduce those both by 5 and it turns into 2 over 1. That's basically what I just did, except I did it cross-canceling. So, of course, times 1 over 1, you're simply just going to have 2 over x minus 2 as your final answer. Because 2 times 1 is 2, x minus 2 times 1 is x minus 2. So there you go. Because everything else canceled out except for that 2 on top and this x minus 2 on bottom. Everything else canceled. So there you go. Let's move on to dividing. So dividing is the exact same thing as multiplying. Literally the exact same thing. All you have to do is set the problem up differently, though. You're going to keep the first rational expression. You're going to change the division sign to multiplication. And then you're going to flip over the second rational expression. So keep, change, flip. You've heard of that before. So let's look at one like this. All we have to do is rewrite it, and then it's the same exact thing we were just doing. So to rewrite this problem as a multiplication problem, we're going to keep this first polynomial exactly the same. 4x to the third over 9x squared y. Now, if you want to start canceling things out, you can, but I'll worry about that later. We're going to change the sign in the middle, so we're changing that to multiplying. And we're going to flip our last fraction. So we're going to put 9y to the fifth on top and 16 on bottom. So there's your keep, your change, and your flip. So you can cross cancel if you want to. There's some things you can do, like 9 over 9. I know that both those 9s are going to cancel out. I'm not too comfortable canceling other things out, although I can. I just think it's going to be a little bit messy if I try to do any more. So let me just put it together and I'll cancel things at the end. So on top, I've got 4x to the third, y to the fifth, if I just multiply this with that. And on the bottom, I have x squared. Well, I guess I should put the 16 first. 16 x squared y on bottom. 16 x squared y. So now there is more to cancel. I can cancel out in this step. So 4 over 16, that reduces to 1 over 4. 3x's on top, 2x's on bottom. Those 2x's will cancel with 2 on top, leaving you with an x on top. And then this y will cancel with one of them up there on top, leaving you 4 y's on top. So a nice, neat answer is just xy to the fourth over 4. But again, that's the exact same thing we did in multiplying. You just need to know the first part, keep, change, flip. So let's try now there where we have to keep, change, flip. So again, there's a lot we can do here in terms of factoring and stuff, but we'll do that in a second. Let's just rewrite our problem. Our problem is keep this first rational expression exactly the same, x to the fifth minus 4x to the third over x squared minus x minus 2. Keep that. I'm going to change the division to multiplying, and then I'm going to flip the other fraction, or the other rational expression. So we're going to put x squared minus 1 on top, and then x to the fifth minus x to the fourth minus 2x to the third on the bottom. So now let's start factoring some stuff. So let's factor this top left one first. So this just has a GCF in it, x to the fifth minus 4x to the third. Both of these terms have an x to the third in common, so I'm going to factor x to the third out. That'll leave me with an x squared minus 4. Now notice, though, x squared minus 4 is still factorable, right? That's a difference of squares. That turns into x plus 2x minus 2. So that's my numerator on my top left is x squared on the outside, and then x plus 2, x minus 2. Let me put a little break here so you don't think that I can tell the difference between them. So that's the top left. Now let's factor the bottom left. So that is my x squared minus x minus 2. So x squared minus x minus 2. It's a trinomial, so I'm going to try using product and sum. So I'm looking for two numbers that multiply to make -2 and add to make -1. In that case, those two numbers would be -2 and +1. So again, since it's 1x squared, a being 1, that tells me that those are my factors, x minus 2 and x plus 1 are my factors. So that's my denominator for that. That's x minus 2, x plus 1. So now let's talk about the right rational expression. On top, I've got x squared minus 1, and that is factorable as well. This is a difference of squares, x squared minus 1. That factors into x plus 1 and x minus 1 by difference of squares. So I'm just going to go ahead and put that up there, x plus 1, x minus 1. And now the denominator, the x to the 5th, down here, x to the 5th minus x to the 4th minus 2x to the 3rd. There is a GCF. I can factor out an x to the 3rd in all of those. So I'll factor an x to the 3rd out. That'll leave me an x squared minus an x, and then minus 2. Because remember, you're dividing out x to the 3 on all of those. So this is still factorable by difference, or not by difference squares, by product and sum. So I'm looking for two numbers that multiply to make -2 and add to make -1. Well, I think we just did that a second ago. It's the exact same thing. So it has the exact same factors of x minus 2 and x plus 1. But don't forget the x to the 3rd on the outside there. So we have x to the 3rd. Hold on, something went a little bit wrong there. I'm like stuck in right-click mode for some reason. I don't know. X to the 3rd, there we go. X to the 3rd, x minus 2, x plus 1. So here we go. Let me again make a larger divide here because that's really getting in the way. So there's a lot of factoring in this one, okay? A lot of factoring, but it's no different than the multiplying problem because now everything's just going to cancel out. But you have to remember to reset up this problem. If you can reset it up and factor, you're basically just good to go. So let's start looking for things to cancel. So this is supposed to be an x to the 3rd, by the way. So I don't know if you pointed that out earlier, but yeah, I wrote that down wrong. That's supposed to be an x to the 3rd. So this x minus, let's use a different color because it's going to be a lot here. So this x minus 2 cancels with this x minus 2, so those are going to go away. This x plus 1 is going to cancel with this x plus 1. This x to the 3rd cancels with this x to the 3rd. I believe that's all the stuff that cancels. So now if you multiply across, the numerator has x plus 2 in it. That's this thing, and then also x minus 1. And the denominator has x plus 1 and x minus 2. So none of those cancel because they're very similar looking polynomials, but they're not the exact same thing. So none of those cancel. So that is what I'm left with as my final answer, as my fully simplified version. It's a handful, but it's one that you can handle if you're good at factoring. You have to be good at factoring. I don't know what else to say. You have to be good at factoring. I think I'll end this video here because these are all basically just the same idea. Just keep factoring them and you're good to go. So I don't want to make too terribly long, but so we'll leave it at that. But what you need to do now is, I think the next video will do adding and subtracting. So I'll see you there. Bye.